Hi everyone. What we're going to be looking at in this segment is looking at the area of velocity time graphs. It's a little different from what we did before. If you remember earlier, we did slopes and we looked at the slope of position time graphs. We also looked at the slope of velocity time graphs. We saw that the slope of a velocity time graph represents the acceleration of the object. So when we find the area of a velocity time graph is a little bit different. So let's look at what happens here. So again, what we're doing is we're going to find the area between the x-axis and each segment of the velocity time graph. So I find it's really helpful if we highlight these two areas or sections. So we're going to be highlighting the x-axis, and we're also going to be highlighting each component of this graph. And what we're going to do is we're going to be finding the area between the x-axis and the lines of the graph, lines that best fit of the graph. So we can find these areas over here. Now to do that, what we probably want to do is you want to break up the area into a more manageable sections. So I'm going to break this shape here into a simple triangle. This will be area A, then a rectangle and a triangle over here. And then over here, finally, you're going to have another triangle. So let's look at what happens when we find the area of each section. Let's look at area A. So area A, we're going to have a simple rectangle. So the rectangle here, to find the area, it's really easy. It's going to be length times width. So in this case, we're going to look at the length. So the length of this, so we look at the height as the length. It's 30 meters per second. So it's positive, so 30 meters per second. I'm going to include the units here. And the width of this would be 2 seconds. So multiply it by 2 seconds. And let's multiply this through. So the numerical value here would be 30 times 2 gives us 60. Let's look at what happens with the units. So here my units, I'm going to have seconds at the top and at the bottom, so they cancel. So you end up with 60 meters. And I want to include a direction, east. So we found that by finding the area, you get a quantity of 60 meters east. In fact, what we found by finding the area is the displacement of the object during this motion. So here, you can write down the area under a VT graph, velocity time graph, represents the displacement. Remember the displacement symbol, change in position of the object. So we found that during this first section here, the object had a velocity of 30 meters per second east, and over 2 seconds, it traveled a total displacement of 60 meters to the east. Kind of makes sense. Well, let's look at area B. Area B is a triangle, so you have to use the triangle formula. So 1/2 base times height, or base times height over 2, whatever you prefer. So in this case, what we've got 1/2, and look at my base. My base here is going from 2 to 5 seconds. So my base here is going to be 3 seconds. So be careful with this. Don't write down 5. So it's that section here, only section B. So 3 seconds. And I'm going to multiply this by my height. So my height here is 30 meters per second. And let's multiply this through, see what happens. So I've got 1 times 3 times 30. So I get 90 meters. And what happens, again, with the units, they're going to, for the seconds, they're going to cancel. So we end up with 90 meters over 2, or 45 meters. And 45 meters towards the east. So during this interval, if you look at the motion, I went from 30 meters per second to a stop, but I was moving this time. I had a velocity actually. Before I came to a stop, I was actually moving. So this whole time I'm moving towards the east, and during this component, I traveled 45 meters towards the east. Then we stopped, and then we started to travel southwards, or sorry, westwards. So when we travel westwards, it means we're traveling in this negative area over here. So we would expect my displacement to be negative as well. So let's calculate that out. So we've got this area C. So again, I'll use the other formula here. So base times height over 2. So here, my base is 2 seconds. Again, you have to be careful here. I'm just looking at this little component here. 2 seconds times my height. Now my height, you've got to be careful. It's negative 20 meters per second, and this is all over 2. So 2 times 2 is 40, divided by 2 gives me 20 again. So I get a value of negative 20. Remember the units here cancel. Meters east. So during this section, I traveled negative 20 east, or 20 meters towards the west. That makes sense. I had a westward velocity here. Now what we can do is I can find my total displacement. So my total displacement is really my resultant displacement, if you remember that from our vectors. And to get this, all I do is I add these different components together. So positive 60 meters east for the first section. Then we traveled 45 meters east. And in the last section, we traveled 20 meters, but towards the west. Oops, east. So when I add all of these up, my final resultant displacement, we're going to get a value of 85 meters towards the east. So overall, for this particular motion, we traveled 85 meters and in an eastward direction. So let's look at another example here. It's very similar to the first. So again, what we want to do here, we want to find the displacement. Actually, we want to find the resultant, or the overall displacement for this particular object. So just like before, I suggest that you highlight the x-axis, highlight the graph itself, and then what we're going to do is we're going to find the area in between the two. If you use this technique, chances are you'll get the right answer. You won't mess up with the area. So again, just like before, what we're going to do is we're going to break this graph into different sections to make it a little bit easier. And we're going to find the area of each individual section. So let's look at area A. So area A is a rectangle. So we're using length times width formula. So in this case, we're going to have length will be our height here. It's a negative value. So negative 4 meters per second and east times my width, which is 2 seconds here. So we get a value of negative 8 meters eastward. So in other words, during this component, I had a velocity, a westward velocity, so it makes sense. I have a westward displacement, or a negative east displacement. Okay, B is very similar, except here we're eventually coming to a stop. So area B, I'd use my base times height over 2 formula. It's a triangle. So we're going to look at the base. My base, again, be careful, is 2 seconds. We're going from 2 to 4 seconds. Just this component. It'll be 2 seconds times my height. So my height is negative 4 meters per second, all over 2. And when we calculate this, you're going to get a value of negative 4 meters to the east. Okay, now during C, I don't have to do very much. C has no height, so we're going to have a 0 displacement. So it's 0 meters for my displacement here. Now D, it's a triangle, so area D is going to be base times height over 2. And what's going to happen is the base here is only 1 second. So it'll be 1 second. And my height here is 4. So 4, it's positive, meters per second all over 2. And you calculate that out. 4 divided by 2 gives you 2 meters east. And it's a positive area. So in other words, it's an eastward displacement. And finally, for our last section here, we're going to be looking at the area of a rectangle. So we're going to be using the length times width formula. So here we're going to get our length, height, will be 4 meters per second. And the base here is going from 7 to 10, 3 seconds. So we get a value of positive 12 meters east. That's my displacement. Now to find the total displacement, or the resultant displacement, you just find the sum of all of these. So the resultant displacement would equal to the sum of all of these. So it's 12 and 2 is 14 minus 4, which would be 10. And you take away the 8, you should end up with an overall 2 meters east displacement. Positive, and that's it. So my displacement for the entire trip, this resultant displacement, again, it would be the sum of all of these, 2 meters to the east. You can see here we've got the area here, the positive area is a little bit larger than the negative area. That's what accounts for this positive value down here. So let's quickly recap what we've done so far. So overall, what we've done is we found the slope of a velocity time graph is the change in velocity or change in time, and that gives me my acceleration. And we can measure it in meters per second, or meters per second squared. They're exactly the same. When we found the area, was equal to the displacement. So we had, when you look at the units, it's meters per second times seconds. They cancel, end up with meters. So again, the displacement. And that's it for finding the area.